Hi everyone, this is the Math 30-1 functions review. This is the question number 9 of the rational section. It says sketch the graph of the following function, and then we're supposed to say the domain, range, and asymptotes and explain the behavior of the function as the absolute value of x gets really, really large. We're going to do all of this kind of all at once because they're all fairly interconnected here. Sketch the graph of the function. Now the very first thing I want to do when I see something like this is I want to factor and see if there's any simplifying I can do. Now, my numerator, I can't do anything to. Okay? X plus 2 is just going to become x plus 2. But x squared minus 4 is a difference of squares, and I'll get x plus 2, x minus 2. And I note that the x plus 2 terms are going to cancel each other out. Now, that tells me that there's a point discontinuity here, that the point discontinuity is going to occur. Okay? So, in other words, I'm going to put it over here. I'm going to have a point discontinuity at x equals negative 2. But this reduces down to 1 over x minus 2. Now, to sketch this, I'm gonna come back to this in just a second. Let's just come over here for a quick second here and recall from the beginning of this chapter, one of the first things we looked at was this graph of y equals 1 over x. Okay, and y equals 1 over x looked like this. Okay, it's called a hyperbola. Okay, and it had a curve like this, It had an asymptote. The y-axis was a vertical asymptote, the x-axis was the horizontal asymptote. Now this equation looks remarkably similar to this one, except with an x minus 2 in the denominator. And now think back to the beginning of this course that x minus 2 means, okay, a horizontal translation to the right. So really what this is going to look like, same sort of thing, but this time the vertical asymptote is going to be 2 units to the right. So the graph's going to look more like this, look more like that. So that's what the function is going to look like, except for one other little thing. That we have a point discontinuity that we just found here at x equals negative 2. Okay, x equals negative 2. Well, come back over here. That's going to be somewhere over here. Let's think, what would the y-coordinate be? Well, how do I figure that out? Now I'm going to put a little dot over here at negative 2. I don't know what the y-coordinate is until I go back to this function right here. Now, this graph is going to be identical. The graph of this will be identical to the graph of this except for that hole. That hole will occur at x equals negative 2. So plug that in, plug negative 2 into the simplified version, and you're going to get 1 over negative 4. So I've got this point discontinuity at negative 2, comma 1 over, or negative 1/4. So let's identify the domain, range, and the asymptotes. Well, my domain, okay, is going to be the set of x values such that x can't equal, and there's a couple things that x can't equal. X can't equal plus or minus 2. Okay, I get that right from here, and I could see that right here. That my point discontinuity, and then from my asymptote there, because remember, this tells me how the asymptote moved. My range, well, nothing really changed vertically. Okay, nothing's really changed vertically. I still can't have 0. The x-axis is still a horizontal asymptote, so it's still a gap in the range. But I've also got this point right here, which tells me that the y-coordinate can't equal negative 1/4. So it's going to be a set of y-coordinates such that y can't equal 0 or negative 1/4. Okay? Now, identify the asymptotes. Well, we've already been talking about those. We've got a vertical asymptote at x is equal to 2, and a horizontal asymptote, okay, at y is equal to 0. Now, the last question here says, explain the behavior of the function as the absolute value of x becomes very, very large. Well, essentially what they mean by that is when absolute value of x means whether you go positively or negatively, x gets really, really large here. Notice that what we're doing here is the function approaches the x-axis. Whoops, sorry, you can't see that. The function approaches the x-axis because it is the horizontal asymptote. That's what's going on when we get further and further away from the origin.